Imagine, for a moment, that you are in a pitch-black room. In front of you is a grand piano, but you've never heard music in your life. You have no concept of notes, scales, or harmony. You begin to press keys at random. At first, all you produce is noise, chaos, but then, from the corner of the room, a voice rises. Wrong note. You press again. Still wrong. After tens of thousands of attempts, that voice falls silent for a second, replaced by a subtle nod of approval. In that moment, a melody begins to emerge from the chaos. Today, we are going to explore the story of finding that right note, the story of how raw data transforms into intelligence. We are diving deep into model training. Get ready, because we're about to see how digital synapses are woven from scratch. Training a model isn't just about feeding it data. It's about revealing the soul hidden within that data. Many people see model training as a form of magic. Give it data, and the AI learns. If only it were that simple. In reality, model training is like a chef's apprenticeship. If you give an apprentice spoiled ingredients, they could be the most talented chef in the world, and the dish will still be a disaster. In data science, we call this garbage in, garbage out. The training process is essentially a war of pattern recognition. When a model looks at millions of cat photos, it doesn't see ears or whiskers. It sees mathematical relationships between pixels and probability distributions in color gradients. At the start of training, the model is completely blind. It assigns random importance to everything. Let's talk technically. An AI model consists of millions, sometimes trillions, as seen in models like GPT-4 of tiny knobs. We call these weights and biases. Training a model means adjusting these knobs to such a precise position that, when an input enters the system, it filters through these dials to reach the correct output. Think of a stock market prediction model. One knob might be highly sensitive to inflation data, while another reacts to company earnings. Throughout training, the model tries to understand how much each knob affects the result. If I turn the inflation knob slightly to the right, my prediction gets closer to reality. This turning process is the very essence of training. Now, let's look under the hood. Model training is an infinite loop consisting of three main stages. Forward, pass. Data enters the system, passes through the knobs, and a prediction comes out. This image is 70% likely to be an airplane. Loss function. This is the reality check. We measure the distance between the model's prediction and the real world. If the image was actually a bird, that 30% error is recorded as loss. The higher the loss, the more ignorant the model is. Backpropagation. Here lies the miracle of mathematics. The model travels backward to find the culprit of the error. Which knob caused this mistake? Using the chain rule from calculus, it calculates each weight's contribution to the error and updates them accordingly. Let's visualize this. Imagine yourself on the summit of a foggy mountain. Your goal is to reach the very bottom of the valley, the point of minimum error. But you can't see you can only feel the slope beneath your feet. With every step, you move in the direction of the steepest descent. We call this gradient descent. If your steps are too large, you'll overshoot the valley and go flying up the opposite slope. If your steps are too small, it will take you centuries to reach the bottom. The hardest part of training is finding that perfect step size, known as the learning rate. To understand the power of model training, let's go back to 2016's a legendary match between AlphaGo and Go. AlphaGo was trained by watching millions of professional Go matches. But it didn't just watch. It played against itself millions of times using reinforcement learning. In move 37, AlphaGo made a move that no human had ever made, a move that seemed illogical to experts. They thought it was a mistake. But that move was the product of a strategy discovered through millions of simulations. The model had made so many mistakes and corrected them during training that it could now see an invisible mathematical path to victory that no human mind could perceive. However, things don't always go perfectly. Sometimes, our model becomes too smart for its own good, which actually makes it foolish. Underfitting the model is too simple to understand the data. It's like trying to explain quantum physics to a toddler. No matter how hard you try, the capacity just isn't there. Overfitting. This is our greatest enemy. Instead of learning the logic of the data, the model memorizes it. It sees that all the cats in your data set are white and creates a rule. A cat must be white. When you show it a black cat, it fails. This is why we split data into a training set and a test set. While the model works on the training set, we constantly examine it with the test set. Are you memorizing, or are you actually learning? When training a model, we don't just give it data and walk away. We have external settings to adjust. Hyperparameters, epochs. How many times will we go through the entire book? Batch size. How much data do we give at once? Learning rate. How fast do we want to learn? These settings are like a conductor's baton. One wrong adjustment, and the entire training session can spiral into chaos. When model training is complete, what stands before us is actually a giant mirror. That mirror reflects the data we gave it, our own biases, and the sum of our knowledge. When a model shows a sign of intelligence, it is actually a victory of the mathematical patterns woven into the universe. Today, if autonomous vehicles can navigate streets and your phone can recognize your voice in a crowded room, It is thanks to that make a mistake and fix it loop repeated billions of times. AI is not just code. It is a quest for perfection filtered through our errors. Will machines one day learn more from their mistakes than what we've taught them? Or will they always need a teacher? Only time will tell. You've just witnessed the workout of a digital brain here on Neural Notebook. In the next episode, we'll examine how these brains actually make decisions. Stay with science. Stay with curiosity.